All right, so recall that a proportional relationship is a relationship between two quantities in which the ratio of one quantity to the other is constant. The graph of a proportional relationship is a line through the origin. Relationships can have a constant rate of change and not be proportional, which is what I said at the beginning. So let's read this example. So the entrance fee for the Mountain World theme park is $20. Visitors can purchase additional $2 tickets for rides and games and food. The equation is y equals 2x plus 20, and that gives the total cost y to visit the park, including purchasing x tickets. And so what we're going to do is we're going to fill out this table of values. We'll do this by hand. I'm going to say 2 times x. In this case, I'm going to plug in 2 plus 20. What's 2 times 2? 4 plus 20 is what? 24. So when I buy 2 tickets, the total cost is $24. Let's do this again. 2 times 4 plus 20. What's 2 times 4? What's 8 plus 20? 28. 2 times 6. 12 plus 20. 32. And another thing we could do, what am I doing here? Adding 4. What am I doing here? Adding 4. What am I doing here? Adding 4. What do you think my next number is going to be? 36. Let's double check. 2 times 8 plus 20. Yeah, it's 16 plus 20, which is 36. Now, what do I do up here to get from 0 to 2? Add 2. Add 2. Add 2. So my slope, which is 2, comes from my change in y, triangle y, over my change in x, which is the rise. I hear somebody saying rise over run, which is equal to 4 over 2, which is equal to 2. Now I just got to plot those points. So when x equals 0, what does y equal? When x equals 0, what does y equal? 20. So that would be right here. When x equals 2, what does y equal? 24. When x, whoops, that's the wrong spot. I'm going to go over to, when x equals 4, what does y equal? 28. When x equals 6, what does y equal? 32. When x equals 10, what does y equal? Somehow I'm drawing these wrong. When x equals 4, it's 28, right? And 6 is 32. 8 is, yeah, and that's interesting that you say that. Really what we're doing is we're going up 4 over 2, right? That's the rise over run. So that's our line. So it's still a straight line. It's just not going through the origin here. See that O? That means origin. So it says plot the ordered pairs. That's what we did, right? Those are points on the line. Then it says find the rate of change from point to point. What's the constant rate of change? Yeah, the slope is equal to 2. And we probably should say 4 over 2, right? And then it says actually calculate y over x from the table of values. And then explain why it's not proportional. Now this one's a little tricky. Well, first of all, what they're saying is, what's 20 over 0? So they want us to figure out what this is, y over x. 20 over 0 is undefined. And then on the next one, we're going to say y over x is equal to 24 over 2, which is 12. And then on the next one, what I'm doing is I'm just getting these points here, 24 divided by 2, 28. So if I say y over x is equal to 28 over 4, that's just 7, right? And then 32 divided by 6, that's 32 divided by 6. Really, that just reduces down to 16 over 3, I think. Which is like a crazy decimal. And so you would say that it's not proportional because remember on the proportional one, these fractions all equal the same thing. So I want you to write it this way. I want you to say y sub 1 over x sub 1, and then put an equal sign with a slash through it. That means not equal to y sub 2 over x sub 2, not equal to y sub 3 over x sub 3, and then y sub 4 x sub 4. So what I'm saying is the first ordered pair, that ratio of y over x does not equal the second pair. And that does not equal the ratio of the third pair. None of them equal. So it's not proportional. But you see that it's a straight line and it's a constant rate of change, but it's not proportional. Yes? Yeah, sure. Okay. Any questions on that so far? All right, so let's move on to the next thing. Don't put your books away. We're